On number 6, the graph of f looks something like this, and it's asking which of the following graphs could be f prime. So we know how to draw f prime given f. We've done this in our derivatives unit. We know that f prime is going to go through the x-axis wherever f is flat, so at maxes, mins, or shoulders. And then we also know that derivative needs to be negative when the function is decreasing and positive when it's increasing. So the function starts by increasing, so our derivative is going to start positive. Starts positive, okay, it's going to come through. Now it's negative because the function is decreasing. The function is still decreasing, and then we hit that flat point again, and now the function's increasing. So which one looks most like that? It looks like that is answer B. Going back to the chain rule, 6 tangent 4x. The outside function is 6 tangent, the inside function is 4x. So f prime is going to be, the derivative of the outside function is 6 secant squared, 4x, and then now we have to multiply by 4, which is obviously like 6 times 4 is 24, so we get 24 secant squared 4x. So that is answer C. All right, f of x equals sine 2x, so it's asking us for the slope of the curve at pi over 3. So we need to first find f prime. So this is going to be a chain rule. Derivative of the outside function is cosine. Leave the inside function alone. Multiply by the derivative of the inside, which is 2. Now we're going to plug in pi over 3 to that derivative. So we get 2 cosine of 2 pi over 3. So cosine is negative in the second quadrant. We are in the second quadrant at 2 pi over 3, and it's going to be equal to negative 1/2. So we get 2 times negative 1/2, which is equal to negative 1, and that is answer A. For number 9, it's cosine cubed 4x, and this is just a weird notation thing with trig functions. I think it's easier for us to rewrite it like this to see the derivative. These are the same, like functionally the same thing, cosine 4x cubed. So basically we're saying we have the outside function is blah cubed. Okay, then we have cosine of blah, and then the furthermost inside function is 4x. Or the most inside function is 4x. So when we find f prime here, it's going to be a double chain rule. The first thing is the derivative of bracket cubed, or blah cubed, is 3. Leave the inside alone, cosine 4x squared. That's just from our power rule. Now we need to work our way in and do the derivative of the next outside function, which is cosine. It's negative sine, leave the inside function, 4x, alone, and now we finally made our way inside to the derivative of 4x, which is just 4. If we look at this, we have a negative times 4 times 3 that we can put outside. So we have that simplifies to negative 12, and then we have cosine 4x, oh no, ERT. Okay, and then that's times sine 4x. Okay, so that one, that is answer B, it looks like, answer B. Last one, we're given an f prime, and it asks us which of the following is a relative extrema. So what we should do is just think about what the critical points are going to be based on what the derivative is. So we know that we're going to have a derivative of 0 at x equals 2, x equals 3, and x equals 4. Right? So we need to figure out what's happening at 2, 3, and 4. Because an extrema is either a max or a min. A shoulder is not an extrema. Extrema is like the most max or the most min in the local area. So we know that the derivative's bouncing at x equals 3, which means that it's not going to switch signs. But it is going to switch signs at x equals 2 and x equals 4. And I'm just going to actually sketch the derivative so we can get an idea here. So this derivative has a degree of 1, 2, 3, 4, 5, 6, right? 6 total. So that means it's going to have an up in behavior. It's going to cross through at 2, 3, and 4. Okay, so it starts up, crosses through at 2, bounces at 3, and then shoulders through at 4. Okay, really doing my best there. But the point is that we can see the function itself, then if this is f prime, is increasing, hits a max, decreasing, 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 hits a shoulder, keeps decreasing, 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 hits a minimum, and then starts increasing. So we have a minimum and a maximum at 1 and 3. So, at 2 and 4. At 2 and 4. So, so that means that 1 and 3 are true. So we are looking for answer C. Sorry, I misread the question. It says, is there a relative max at x equals 2? No, yes, there is. Okay. Is there a relative min at x equals 3? No, there's not. Is there a relative max at x equals 4? No, there's not. X equals 4 we said was a min, so the only one that's true is actually A. Okay, so not C. And this graph is weird because there should be, like, this is 1, 2, 3, 4. So we have our max at 2, we have our shoulder at 3, and then we have our minimum at 4. So the only true statement then is A.